Hello everyone, myself Krishnal Mahajan and I am a student of GHRCEM College of Engineering and Management Pune, and today I'm here to show you one of the exciting projects on which me and my team were working on. Yep, it is the lung cancer detection using Python in machine learning. We know that lung cancer is one of the most deadliest diseases not only in the India but all over the globe, which has a very high death rates after the pandemic, obviously, but it's very high with a very high death rates, and most of the people are suffering continuously with the lung cancers. So it's very important to detect the lung cancer in the early stages if we want to get recover from it. Because if we are failed to detect the lung cancer in the early stages, it starts spreading in all over the body, and our body is completely affected with the lung cancers, and that particular person is lead to a death. So it's very important to identify the lung cancer in early stages. So here our objective, the main objective of a program is to detect the it helps the doctors to assess and detect the lung cancer in the early stages and help the patients to get recover from it and recover from it without getting much spreadation of that lung cancer. So another objective of our product of our model is to achieve the perfect accuracy and the highly efficiency of the model. So still we are now using this less data like 100 to 200 data set we are continuously providing to the machine, and we are getting the accuracy of the 70%. And I hope if we increase the data set to thousands and 2000, we can achieve the more amount of accuracy and more perfect prediction of that particular model. So now in background here we are using the pandas library, numpy library, some OS operations we are doing, some matplot libraries like cbons and the kirals model. We will talk briefly about them in the next further when we are talking about the workflow of the model. Some CSV2 and TensorFlows and Keras library we are working on this model. So without spending lots of time, let's go and let's dive into the workflow of our model. Workflow. It shows how our model is created, and it tells us how it's predicting the output. So the first step of our model is to loading the data set. As we are know, I'm here using the image processing technique to identify the lung cancer. So therefore, we are using the lots of data in the form of images, which was just generated with the help of CT scans and MRI. Here, lots of data has taken, for example, like 2000, 3000, 4000 of images just for the training purpose. This data are labeled data, which means we are taking the normal data plus affected data, so which will help the training phase in the further steps of a workflow. Okay, once we collected the data, the next step is the exploratory data analysis. Exploratory data analysis, I guess it's my personal favorite step in the model creation. I hope everyone's personal favorite also, because in exploratory data analysis, we are performing the data model, converting data in the form of a graphs. And we know that graphs are the best visual analysis of of our models and data sets. With the help of the visual analysis, we can easily find out the patterns between the data sets, and it helps us to analyze the data. Analyze the data. So with the help of a matplotlib and the Seaborn library, we can perform various graphical representation of our data. For example, like histogram, bar chart, pie chart. There are different types of charts available, and the graphs are available, so we can easily analyze the data with the help of a 3D and 2D graphs. So the next step coming is the data pre-processing. We know that whenever we are extracting the data set from the various sources like Kaggle and like CT scan and MRI, it was not in the perfect form that we can directly implement it to the our machine learning model. So us being a part of the AI and ML as or the AI engineer and ML engineer, it's our work to pre-process that data. Pre-processing technique uses efforts to like resizing the size of image or like converting the text of the image into the numeric forms. We know that whenever we're working with the linear regression model never work with the labeled data or like data which is containing text in it. So when we are using the regression models, so we need to pre-process them in the form of numeric forms. For example, with the help of NumPy libraries, we are converting the text into the numeric form, and we are providing the data to the machine, so it analyze the data and further it predict the what we are expecting from it. So here we are processing as images, so we are we can increasing the size according to our model, and we are finding the and creating the images perfect enough so we can easily use in our model creation. So the next step, let's talk about which model we are working in this which model we are working on. So in this project, we are using the TensorFlow's Chiral model, from which we are using the convolution neural network CNN. CNN is one of the best algorithms used to detect the patterns, to identify the patterns from the images after the SVM. SVM is also used to detect the images or to find out the pattern between images, but SVM is a bit complicated with as compared to CNN. CNN is the easier, and it provides various functionality to analyze the data and to find out the patterns between the data with the help of a CNN. Okay. So CNN is a type of supervised learning models. Therefore, we have to give us a label data in it. Now, let's talk about the training phase. I'm continuously talking about training phase. So now let's talk about what training phase exactly meaning is. So in the training phase, we are the data which we just gathered in the loading data set in the phase, and the activity data analysis, the pre-process the data. That data is now we are feeding to our model, and after feeding, which means we are training the model so it can predict the output. So as we are using the CNN, CNN is the supervised learning model. So here we are using the label data. Label data, which exactly meaning is we are providing the data which is like for example trust data, a normal lung and an affected lung. That data is we are providing into the machine learning, and with the help of that data, we are training our models to predict the output. Okay, so label data, we get it. And so we are once the training phase is completed and a model is completely learned from the data, 70% data which we provided to the machine. Now the second step coming is a testing phase. Okay, testing phase is used to find whether the model which we have created and just generated it was working perfectly fine for the testing or unknown data or not. So in this phase, we're providing 30% remaining data to the machine, and we're trying to check whether the model is perfectly working fine for the 30% remaining data or not. We are providing the unknown data. For example, if any patient has just came and he want to check whether it's affected from the lung cancer or not, we will just take out the CT scans and MRI and put that the images or the CT scan image into our model, and now model will detect whether the person is perfectly fine or affecting by any lung cancer or something like that. So there how the training phase works. Okay. Now here we are completely done with the training phase, testing phase, data exploratory, and data processing. Now let's talk about the result and improvement model analysis. The part of model analysis. So we have talked about how the result has achieving and how we are getting the result. Whenever any new, suppose any patient just came, he want to check whether he's affected from the lung cancer or not. He will just take the CT scans and MRI of his lungs, and he will upload the data into the model. Model will find whether he's fine, perfectly fine, or he's having any lung cancer or something like that. Now, improvement. We are continuously asking for the feedback from the various highly trained professional medical professionals so we can increase the efficiency and accuracy of the model. We know that completely 100% accuracy was not possible. So we are trying to achieve the 99 or 90% accuracy. We are currently on the 70% accuracy with the less data. And we're continuously asking for the medical professionals so they can provide us the feedback. On their feedback, we will increase the efficiency and accuracy of the model. Okay, there are some hardware requirements which I prefer to use this model processor i5 and above. It's very important to use i5, i6, i7, and i9 because if you use i3 or any less processor, no, it's very difficult to pre-process the image on that lower processor computers because if I to tell you my story, when I am performing the processing on i5 generation laptop. So once I completed the pre-processing 670 image, my laptop started evaporating. Like it was so heated up that I can't even pick it up with my hands because pre-processing techniques really produce the complete use of CPU and the hard disk. So it really put lots of pressure and load on the computer CPUs. So therefore, I consider to use i5 and above processors. Hard disk, you should have 10 GB of storage, so we can easily perform the various operation. RAM, it's on you. You can use 8 GB, 16 GB, 32 GB RAM, no problem in it. And another, they are optionals. Monitor, CPU, keyboards, they are optional things. Software requirement platform, you can use Windows, Linux, or Mac OS. It depends on you what you want to use. You can do. Operating system also depends on you. Windows, Linux, and Mac OS. You can use that. Technology. I'm using the machine learning, and machine learning model is created. Therefore, machine learning is important to use. Scripting language Python. If we tell you in today's century, Python is one of the most advanced advanced language. It helps us to do the machine learning, perform machine learning, and various help give us the various help of various libraries. So Python is more considerable for the machine learning, and in today's century, Python is more in demand. Nowadays, more in demand. ID, you can use a Jupyter notebook or you can use prefer the VS Code. VS Code is also best for the generative machine learning analysis because VS Code also provide various of various features, so we can easily perform the model creation and training. Future scope. So our model helps the doctors to prevent to detect the diseases in the early detection. So it is one of the innovative program which uses skills of machine learning and the Python together. So it helps the patients to save their lives. So I hope in the future, I have talked earlier, if you increase the number of data set, or we can change the model if any highly advanced model came in the future. So it can model be also give us the 100% accuracy. And it's very important in today's world. Everything is going to be the AI based. So if the in medical sciences, if we use the AI to detect these diseases, so it's very helpful to prevent the people from death and such dangerous diseases. Conclusion. So in this model, we have taken data set from the Kaggle for the data lung cancer detection. You can use any site which you can if you want to use. There are lots of data set sites available in the Google. You just need to Google it data set for the image processing for the lung cancer. You will get lots of data sets available on the future. And Google, you can also take images from directly the database of the any hospital near hospital if you are having access to them, and find some references which we have taken references like a research paper. You just go to the Google Scholar and search for references of the research paper for the particular machine learning model. So here there are some which we have used and on according to which we have created our model. Okay. So in last, thank you so much for tuning with me today. I hope you learned something, and if you like our project, please like the video. And if you have any question regarding to the project, you can just comment down below, and together let's make a difference. Thank you so much. Sayonara.